At 8:10 a.m. local time yesterday on June 24th, the ground began to shake back and forth in Western California. A moderate magnitude 5.6 quake had just struck, and due to its fairly shallow depths, strong shaking equivalent to this simulation showing MMI 7.4 intensity ground motion, which was the absolute maximum a single spot experienced. Items fell off of shelves, and thousands of homes were soon temporarily out of power, but despite the intensity of the shaking, no notable structural damage or injuries were reported. And I'd like to at least partially attribute that fact to California's strong building codes. While some limited landslides and liquefaction may have occurred, if it did, models suggest few, if any, people were affected. The earthquake in question did not involve the San Andreas Fault, but rather a different lengthy fault to the east known as the Maacama Fault. Stretching for 104 miles in length, this fault line moves an average of 0.8 centimeters or 0.31 inches a year, and hypothetically could, in a worst-case scenario, be technically capable of producing an earthquake of up to magnitude 7.5. However, no previous quakes larger than magnitude 5.6 had ever struck this fault line in the area of local historical records, meaning that yes, yesterday's earthquake ties the record for the largest known seismic event to have struck the Maacama Fault, tying with an 1869 earthquake. But why has this fault proven to be a localized cluster of seismic activity in the first place? Well, in California south of Cape Mendocino, the Pacific plate is sliding upwards against the North American plate, while the vast majority of this motion and stress is transferred to the San Andreas Fault, about 75%, and around 15% to faults in the Walker Lane province. The remaining 10% is accommodated by other local faults. Stress built up due to the motion of these two tectonic plates on a segment of the Maacama Fault Zone until what I estimate was a 5.05 mile or 8.13 kilometer long segment of it slipped, generating an earthquake. However, those of you with keen eyes might have noticed that yesterday's earthquake did not seemingly occur on the Maacama Fault line proper. And this takes into account the oblique right lateral strike slip nature of the earthquake and its 54-degree dip. Instead, I suspect that a smaller buried fault line is to blame, which paralleled the Maacama Fault at the very edge of its broader fault zone, or series of somewhat closely spaced faults. That puts the actual surface expression, if there is one, of the fault line which produced it within a radius of 3 miles of the epicenter. While no specific faults with surface expressions have been mapped in this zone, there are seemingly 3 lineaments that cut across local Franciscan complex rock units, which could represent the surface expression of our missing fault line that I have highlighted, which would match the exact strike the fault slipped at from the magnitude 5.6 earthquake. Already, 38 aftershocks, or additional generally smaller magnitude earthquakes following the main shock, have struck. But statistically, while these will continue occurring for a time, each day that passes should see their abundance decrease. Here's a statistical aftershock forecast chart for various magnitude earthquakes in a set time period. As you can see, the chance of an earthquake in the next week following, which is larger than the magnitude 5.6 quake, is technically possible, but considered highly unlikely. Besides, around the world, only about 5% of earthquakes denote foreshocks to an even larger magnitude nearby earthquake in the next week, which means a 95% chance of no larger than magnitude 5.6 quake striking in the vicinity during that time period. I hope that you found this video interesting, and if you would like to request a specific video topic for me to cover, please leave a comment below. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.